I keep losing to you at this game. I'm always half a second behind.
Oh, maybe I'm just faster than you.
Well, I keep getting tripped up when the heart is a different color.
That's funny. I find it hardest when they're all the same color and I have to focus on the shapes.
I wonder if there's some mechanical differences between us that make these parts harder.
What does that even mean?
So, you know about the HCI model of human interaction, right? Like the model,
HCI?
human computer interaction. Basically, it says that the user and the computer are two systems that are communicating with each other.
In our case, it's more like player and game.
Right. And those communications happen in these mediated ways. So, like, the game tells me to do something, like make my guy look at the heart, and it communicates to me with pictures and sounds. And then in my brain, it gets that and uses all of my thinking processes to be like, okay, where is the heart? And responds with me pushing the joystick. The game hears that and moves my guy and tells me whether that's right. That's like a full conversation.
So, what does that have to do with mechanical differences?
Well, you and I are pretty different, right? Like maybe your brain is better at noticing hearts than mine. So that part of the communication where you think and respond happens faster than me.
Well, that makes sense. Like that other minigame we were playing where we had to remember the order of the objects. I could never remember more than a couple, but you seem to remember the whole screen.
Yeah, that's what I'm saying. We all have different abilities and proficiencies. And if we could have a good model of these things, maybe we could get a way to understand why I suck at the heart minigame, but can kick your butt on the memory one. Maybe something like the model human processor.
Yeah, but models are so imprecise. I mean, look at that one. Cognitive processor? What does that even mean? Finding the right heart and having memory are both cognitive, and you're telling me to abstract them together? We've got to be able to come up with something more tangible than that. What about types?
Types, like player types, like Bartle and all that, we've been there, and there are issues.
No, 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 not player types. Type types, like programming languages.
So, how would we even have something like that? Aren't types just concrete things? Like, wouldn't every player be their own type?
There's all sorts of ways to define types. A very useful way to think about them is as a syntactic language for representing statically known properties. Here we could think of representing constraints.
You've lost me.
All right, all right. Bring back the human model human processor. So imprecise. But it does give us some ideas about how long information takes to decay in your memory, or on average, how long it takes for a motor response. And look here, there's all this research from CogSci about how long each operation takes. What if we took this data and made types based on the constraints of these abilities?
So, how would this kind of system even work?
Well, generically, it would look like this, where we translate measures into time constraints. One tricky part is that our motor psychomotor system does work somewhat in parallel. So some of these things can overlap.
Okay, but how would that help?
Um, so say that a player uses a process P. I think you're a bit behind on the slides. Um, for a challenge, for a focus challenge C. If they're able to sometimes perform P at a time shorter than what the game considers to be acceptable, then the challenge is achievable by that player.
And what if they can't?
Well, then clearly they'll be very frustrated. In fact, it's even bad if those two times are very close, as the amount of effort and stress induced might be too high.
So, if a designer knew this ahead of time, they could adapt things to reduce frustration to a level that's more consistent with something like flow. Is that what you meant by static property?
Yes, exactly. Now, generic measures, like we have on the left, are too crude. It would be way more useful if we could get player centric measures of their own psychomotor processes.
Well, that actually could be kind of neat. It would definitely allow us to describe what we've been talking about, but in a more specific way.
I think it would allow us to do a lot more than that. Think about user testing. Industry spends so much time just throwing hours of ad hoc testing at games. Professional testers get really good at games. With something like this, we could type check the design before it gets implemented, knowing right away whether the game is playable by the target audience.
Or even knowing whether the game is unintentionally keeping whole groups of people from playing. A lot of accessibility options and testing we have now come from either guidelines or designers' personal experiences. This could be a way to check whether a game has met accessibility standards.
Possibly, there's always the potential that cool ideas are used to enforce ableism instead. But the hope is that something like this can make it a metric that people can't look away from. That knowing these things makes people aware of how they contribute to the problem in conscious and unconscious ways.
Like adaptive gaming, it's a tool that can do a lot of good, but depending on the settings and how it's used, it can also be something that players despise.
Indeed. But we still have a whole lot of lingering questions like,
Does this idea even extend to other types of games and types of experiences? It feels like it heavily ties to the ideas of flow and optimal experience in gaming, which don't always leave spaces for more narrative and emotional experiences.
yeah, and even the bits we have, do the types of constraints we're talking about even make sense? We're working on such low level operation. Is it even possible to differentiate between things like memory processes and attentional processes?
Or even expanding outwards. We're talking about mini games here, things that take place over 10 seconds max. What about longer games? Do these constraints even matter then? Or do we move into a whole different order of timescales and operations?
And what about that composition bit? Seems a little iffy. Um, I know that the FRP people have definitely cooked up some really cool ideas here, and there's obvious expansions that would involve distributions instead of flat intervals, and parameters to tweak for things like fatigue and cognitive load, and so much more.
So maybe we should bring it to some other people to talk about more. Maybe they've played games like this and had similar ideas to us. So we'd like to open the floor to discussion here.